The principle of conservation of momentum states that the total momentum in a closed system cannot change after a collision. So we can summarize this principle using the equation total momentum before a collision is equal to the total momentum after a collision. Remember that to find a momentum, we simply multiply the velocity of an object by its mass. Let's try to understand this equation more by looking at a general way it can be used. Suppose we have two balls and we look at their behaviour before and after a collision. We'll use this dotted line to separate the before and after information. The balls have two different masses. Let's label them m1 and m2. They also have velocity, which we'll label u1 and u2. This is the same notation for initial velocity that we use in the uniform acceleration equation. So the total momentum of the two balls is m1u1 plus m2u2. Remember that momentum is a vector, so it's important that we use these arrows to show the direction of the balls. If they travel in opposite directions, then either m1u1 or m2u2 will be negative. Now for the momentum after the collision. The two balls will still have the same mass, m1 and m2, but their velocities will have changed because of the collision. So we'll write them now as v1 and v2, where the letter v is used to represent final velocities. So we have a total momentum of m1v1 plus m2v2. Again, we need to check the directions of the momenta carefully and determine if they're positive or negative. The principle of conservation of momentum tells us that these two sums must be the same. So we can write that m1u1 plus m2u2 equals m1v1 plus m2v2. We can then use this equation to say find v1 if we know the masses and the other three velocities. You don't need to be able to recall this algebraic form of the equation. In fact, this equation only applies to this specific example. For your exam, you'll need to be able to apply this general rule for conservation of momentum and how to calculate individual momenta in a variety of contexts. Let's go through a question similar to this example now. Two trolleys of masses 0.5 kilograms and 0.2 kilograms are projected towards each other with speeds of 2 meters per second and 1.5 meters per second respectively. After colliding, the 0.5 kilogram trolley continues moving in the same direction with a new speed of 0.8 meters per second. Calculate the velocity of the 0.2 kilogram trolley after the collision. Now that's a lot of information, so we should start with step 1. Sketch and label a diagram of the collision described. Here we have the two trolleys before and after the collision, with this dotted line to separate the two times. We're told that the first trolley has a mass of 0.5 kilograms, and the second a mass of 0.2 kilograms. Now for the velocities. It's not specified which direction the first trolley is moving in, so we can just say it's moving to the right. We'll also call this our positive direction for the rest of the question. We're then told that the first trolley has a speed of 2 meters per second. Now for the second trolley. Here we need to read the question carefully. It says that before the collision, the two trolleys were projected towards each other. So that means the second trolley was moving in the opposite direction to the first, to the left. Then it has a speed of 1.5 meters per second. Remember that we'll need to treat this as a negative number during our calculation. Next, let's see what information we can list for after the collision. Firstly, we know that the trolleys will still have masses of 0.5 kilograms and 0.2 kilograms. Then we're told that the 0.5 kilogram trolley continues moving in the same direction, so it still moves to the right. We're also told it has a speed of 0.8 meters per second, which will be positive. We're not told anything about the new velocity of the other trolley though. Let's assume for now that it's positive and moving to the right, which we'll correct later if we find a negative value. We'll then use the letter v to represent this velocity, which is what the question wants us to find. An exam question won't require you to draw a diagram for your answer, but as you can see, we've got lots of speeds, masses, and directions to consider. A diagram like this one is the best way of ensuring you don't get the details mixed up during your working. Then for step 2, calculate the total momentum before the collision. We'll do this by calculating the individual momenta using the equation momentum equals mass multiplied by velocity, and then add them together. So the total momentum is equal to the momentum of the first trolley, which is 0.5 kilograms times by 2 meters per second, plus the momentum of the second trolley. Here we need to remember to use a negative velocity as it travels in the opposite direction to the first. So this is 0.2 kilograms times by minus 1.5 meters per second. Putting this together gives a total momentum of 0.7 kilogram meters per second. Also note that this is a positive value. For step 3, determine the total momentum after the collision. So this is where we need to bring in the principle of conservation of momentum. So we know that the total momentum after the collision must be equal to the total momentum before the collision. In other words, the total momentum after the collision is also equal to 0.7 kilogram meters per second, and it's a positive value. We can use this total to find the momentum of the 0.2 kilogram trolley after the collision and use that momentum to find its velocity. But there's another step we need to do first. In step 4, calculate the momentum of the 0.5 kilogram trolley after the collision. Again, we'll be using the momentum equation, momentum equals mass multiplied by velocity. So we have that the new momentum of the 0.5 kilogram trolley is 0.5 times by 0.8, where we have a positive value for the velocity as it's moving in the same direction. This gives a momentum of 0.4 kilogram meters per second. Then in step 5, calculate the momentum of the 0.2 kilogram trolley after the collision. So let's sum up what we know so far. We've found that the total momentum after the collision is 0.7, and the momentum of the first trolley is 0.4. So the momentum is equal to 0.7 kilogram meters per second minus 0.4 kilogram meters per second. This gives a momentum of 0.3 kilogram meters per second. Notice that we have a positive value for our momentum, which implies the trolley is now travelling to the right. We'll confirm this when we've calculated the velocity. In step 6, rearrange the momentum equation to make velocity the subject. So we have that momentum equals mass times by velocity, and in order to make the velocity the subject, we have to move mass to the other side. This is done by dividing both sides by mass, since we're multiplying the velocity by this. This gives us that momentum divided by mass is equal to the velocity. Now for the final step. In step 7, calculate the velocity of the 0.2 kilogram trolley after the collision. So if we flip the equation we previously found, we have that velocity is equal to the momentum divided by the mass. So to find the velocity of the second trolley, we do 0.3 kilogram meters per second divided by 0.2 kilograms. This gives a value of 1.5 meters per second. Remember that during the first step, when we were drawing our diagram, we said that objects travelling to the right would have positive velocities. So since this velocity is positive, we know that the 0.2 kilogram trolley must be travelling to the right after the collision. Now that was quite a long calculation, but one you need to be comfortable doing in a variety of contexts. This is a topic that's worth doing as many practice questions as possible for.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!